All right, so I'm going to walk you through lesson number 2, which is the formal definition of a function. Make sure you have this sheet and make sure you put it in between page 6 and page 7 in your binder. So first and foremost, you need to know what a function is. So a function, it's a rule that assigns to each input exactly one output. This definition is going to be very important for you today going through your classwork. So again, a function is a rule that assigns to each input exactly one output. So there's different ways that a function can be represented. It can be represented as a graph. It can be represented as an equation. It can be represented as a table. It can be represented as words. It can also be represented as a formula, or it could be represented as a rule. So now I'm going to go through a little thing and explain to you why a function assigns each input to one output. So I want you to consider this. Take a look at this table. At 1 second, our distance traveled is 4 feet. Yet underneath it, we have 1 second again, we're traveled at 36 feet. So does that make sense that at the same time, at 1 second, you're at 4 feet and 36 feet? That's not possible at 1 second in time to be at two different distances. So notice, get that out of the way for us. So notice how 1 is repeated twice. That's why this table isn't a function. The input of 1 has two outputs. Remember, the definition says it's supposed to have exactly 1. So if I ignore the x's, if I look on the y side, notice how I have 4 and 4 for feet traveled. Isn't that possible that at 0.5 seconds you're at 4 feet? And then at the other when you moved up to 1 second, you didn't move at all. So it's completely okay to have the same output twice. However, when you have the input with two outputs, that makes it's no longer a function. So let's go ahead. I need you to flip your sheet in your notes. We're going to take a look at exercise 1. So we're going to let y be the distance traveled in time. We're going to use this function. This is also a formula. Didn't we say a function can be represented as a formula? And we're going to calculate the distance the stone dropped for the given time t. Oh, here's my table. 3 different ways we're representing it already. So I'm going to cross out A and B. We're not going to worry about that for today. And I'm going to do the work for when I fill in my table in the spot below. So all you need to do, you need to use your equation, y equals 16 t squared, and I'm going to plug in my different t values. Notice how I have 0.5, 1, 1.5, 2, 2.53, 3.5, and 4. So I'm going to plug in 0.5. So I have y equals 16 times 0.5 squared. Make sure that you know where the squared button is on your calculator. If you look, I pulled up a scientific calculator. Here is your squared button. If you don't know how to plug in your squared button, remember if it's 0.5 squared, it really means 0.5 times 0.5. If you're not sure, quietly ask someone next to you or around you to help you find the squared button. So now when I plug it into my calculator, I end up with 4 feet. I'm going to need you to go ahead and I need you to complete the rest of the table. You can do that now and pause the video, or you can continue watching the video and go back to it afterwards. There's a few other things I want to make sure that I talk to you about. So if I look at number 2, we want to figure out, could the table below represent a function? Remember, each input has to have exactly one output. So 1 has one output, 3 has one output, 5 goes to 19, but 5 also goes to 20. Since 5 goes to 2 different numbers, it's listed twice. Since 5 has 2 outputs, it's not a function. So I'm going to say no, this is not a function. Because the input of 5 has 2 outputs. $19 and $20. Again, I need you to do number 3 and number 4. You can pause the video and work on them now, or you can go back to them after. I'm going to go ahead and we're going to look at number 5. So we have, it takes Josephine 34 minutes to complete her homework assignment of 10 problems. If we assume that she works at a constant rate, we can describe the situation using a function. Predict how many problems Josephine can complete in 25 minutes. Be reasonable. If in 34 minutes she completes 10 problems, if we have less time, shouldn't we complete less problems? So I need you to come up with a prediction. I'm going to help write a 2-variable linear equation that represents Josephine's constant work. In your binder, underneath B, I need you to write this. Write the rule that describes the function. These 2 questions are essentially the same thing. It's 2 different ways of asking for the same work. So when I need to write the rule or the linear equation, remember I have minutes is on the bottom and problems goes on top. Remember, this is where I always told you you're going to be left with y over x. Now I'm just going to fill in the amount of problems that Josephine completed was 10 in 34 minutes. I'm going to go ahead and cross multiply. I get 34y equals 10x. Again, you should know this. You always solve for y. So I'm going to go ahead, divide each side by 34. My 34s cancel. I'm going to write it down here. And I'm left with y equals, I'm going to leave that fraction the same, 10 over 34x. If you do plug it into your calculator, it's an ugly decimal. It doesn't really tell us where to round, so I'm going to leave it as is. So now you should be able to complete part C. You have to use the equation that we just wrote, which is here, and you need to complete the table. You need to round your answers to the hundredths place. Remember, when you round, if you have 126.356, 5 is in your hundredths place, you have to look to the right. It's either going to tell it to bump up 1 or to stay the same. So this example would round to 126 in 36 hundredths. So again, you can pause the video here to complete your table, or you can complete it afterwards. Something that I want to make sure that you do catch, after 5 minutes, Josephine was able to complete 1.47 problems. So what that really means is she completed at least one question, and she was halfway through the next question. So for part D, all I want you to do is compare your prediction from the actual number in your table. Remember, your prediction was based on 25 minutes. So you got to look back in your table and write me a sentence. Were they the same? Were they different? Explain for me, please. For part E, you have to use the formula again from part B. Oh, that formula was y equals 10 over 34x. And we're going to compute the number of problems that was represented by y when x is negative 7. That means it's negative 7 minutes. So instead of writing x, now I'm going to erase it, and I'm going to plug in negative 7. When you plug into your calculator, you get y equals negative 2.06, I believe. So we have to answer, does our answer make sense? Does it make sense? Now I got to look back in the context of the problem. X was negative 7 minutes. Y is the number of problems. Does it make sense for Josephine in a negative amount of time to complete negative problems? Is it even possible to have a negative amount of minutes? So I'm going to say no. The answer doesn't make sense. Because, and I am saying because, it has this word explain, because you cannot have a negative time. Last question I'm going to walk you through. So for part F, for this problem, we assume that Josephine worked at a constant rate. Do you think this is a reasonable assumption? So remember, she was working on homework. So at home, when you do your homework, does it take you the same amount of time for each question? I'm guessing probably not. Since people normally, questions are easier, they get harder as you go along. Homework normally isn't done at the same rate. So I'm going to say no, this is not a reasonable assumption. Because, remember, it says explain. It's not a reasonable assumption because Josephine might spend longer on one question than she does another. So that's part of being a human. You don't do things at the same rate. Just like, for example, me running, I'm not running at a constant rate normally, just like people walking, unless you're on a treadmill, just like people typing, right? All these things that we do every day, we don't do at a constant rate. Just like me teaching from one class to the next, I don't finish in the same amount of time. So your to-do list for today is to make sure you need to finish lesson number 2. Make sure you finish the questions that I asked you to finish. You can start your problem set. This is going to be your homework, yet if there is time at the end of class, you need to start this now. You need to do numbers 1 through 5 and number 9. There are exit tickets up by the phone, and you need to do that as well and put it in the inbox.